The wire can only pull directly in the direction it's at. It's like a rope. It's pulled whatever direction it's in, that's which way it's being pulled. It doesn't have any strength side to side. So the wire's being pulled just like this, but you break the X and Y components. This is the X component, and this is the Y component. We know that this Y component is lifting half of this, so that's 490, right? Okay, so now we just got to do some trigonometry, geometry stuff, and we can calculate, well, what's this side of the triangle, right? More or less than 490.
You say more or less?
More or less than 490.
It's going to be more.
It's going to be more.
Isn't there a similar ratio for triangles that have two 45-degree angles?
Yeah, it's
1 and 1 over square root of 2.
1 square root of 2. Yep. So it's square root of 2 times 490.
$692.96.
693. 45. Wait. A right triangle that's got a 45 and a 45 is 1 square root of 2. That's the ratio of the three sides. It's a special case, kind of like the 30, 60, 90. The 45, 45 is another special case. It's 1 square root of 2. So this side here is the hypotenuse is the square root of 2 times as much as the 490. So he did a shortcut. He did 490 times the square root of 2. You don't have to do it that way. The other way you can do this thing, if this is 45 degrees here, this is also 45, right? So then we go back and use the SOHCAHTOA. And that's really kind of what you need to remember, because most times it's not going to be 45 degrees. That's just kind of the special.
So the 693 that you wrote there, is that the hypotenuse?
Yes. Let's work it with SOHCAHTOA here. Make sure everybody is clear on this. So we've got a adjacent, we want hypotenuse. So we want cosine. Is equal to 490 over the hypotenuse. So we've got 45 cosine 490 divided inverse 693 newtons. Okay, now remember last time I said we were talking about what this thing would look like if it was at different angles. We do the same problem with it like this. Versus if it's like this. Remember that? Now, think of what you just learned about these triangles here, and think about the force in the line. In each of these cases, this y component is what? What's the y component of this line? Look at this. It's the same as here. It's 490, right?
50.
Well, it's got to lift 50 kilograms, so it's 490 newtons. So this line is almost the same length as this one. It's just a little bit more than the 490, right? How about on this one? Look at all the dashes. It's a lot more than 490. It's 2 or 3 times 400. It's like 1,500 or something. So you know, think of me sitting in this ring. I'm not a small person, and you try to pull that line until the rope is straight across. Does that bring it to fruition? You're going to pull pretty dang hard. You can't get it flat because I'm always deflecting a little bit. You have to pull infinitely hard to get that line completely straight. Okay.